Hey, how's it going? It's Mr. Farrow here with another physics tutorial. Today's is on displacement, which is represented by delta x, okay? In today's problem, we're gonna be working with displacement. Okay, we're not directly dealing with the displacement equation. Instead, we're gonna look at a problem where there is a bunch of displacement and we've gotta combine it all to find the net displacement or the total displacement, okay? In this problem, we're only dealing with two-dimensional motion, so that would be east and west or north and south. We're not gonna combine north with east or north with west, okay? We're just focused on just the one two-dimensional plane, okay? So in this problem, we're dealing with east and west, all right? And we're going to use our ICE method to solve this problem. Now, we don't, again, have an equation that we're really using to solve this problem, but we're going to walk through these steps anyway just to continue to familiarize ourselves with them. Again, they stand for identify, categorize, equate, and evaluate, okay? So let's go ahead and jump into this problem. It reads, Austin travels 4 meters west. He takes a short break and travels 22 meters east. He then walks 17 meters east. After another short break, Austin travels 6 meters east. And finally, he turns around and walks 30 meters west. What is Austin's displacement? Okay, so our first step in the ICE method is to identify all of our measurements and our question that the problem is asking us. So remember, when we identify our measurements, we are looking for the number along with the unit, all right, and the direction if we're given a direction. So let's go ahead. In this problem, we see Austin travels 4 meters west. Okay, so I'm going to use my blue marker here. We just identified our first measurement. We have the number 4 followed by a unit, okay, meters, a unit of displacement, and we have a direction also, west. So we want to make sure to get all of that. Let's see, 22 meters east, that's another one. I see walk 17 meters east, 6 meters east, all right, and 30 meters west. Excellent. So we got some measurements there, all right, and here is the question of the problem. It says, what is Austin's displacement? Okay, excellent. So we have identified 5 different measurements in one question in the problem. All right, so we're going to go ahead and cross off the I in the ICE method because we've identified all of our measurements in the question. Now let's go to our categorize step. So when we categorize, we need to put all of our measurements into a category, okay? Now they are all displacements, we know that, okay? So we're going to combine all of these displacements. So let me just write them down here. So we have 22 meters east. Oh, let me start with the 4 meters west. Almost missed that one. So 4 meters west, 22 meters east, 17 meters east, 6 meters east, and 30 meters west. Okay, so these are all of our individual displacements, all right? And our question is, let me put the question mark there, just like that. All right, don't know if you all can see it. I'm gonna scoot this down a little bit. All right, sweet. So we've got all of our displacements from the problem listed, and we've got our question. Now, let's go ahead and categorize these. So we're gonna first start with our first measurement. Now, when we see that it says west, we know that we're gonna have to decide which direction is positive and which one is negative. Okay, so I'm gonna go over here and let's decide that west is our negative direction and east is our positive direction. Now this is completely arbitrary. I could have decided for west to be positive and east to be negative. It doesn't matter, we just have to choose a convention and be consistent, okay? So now that I know that west is my negative direction, I'm gonna rewrite this. Instead of west, I'm gonna write it as a -4, okay? -4 meters, because anything that is negative is going west, all right? Now, 22 meters east, my east is my positive direction, so I'm just gonna put positive 22 meters. Again, I have another east, so that is another positive 17 meters. Again, another east here, so that's gonna be a positive 6 meters, okay? Positive because it's in the east direction. And then 30 meters west, I'm gonna go ahead and mark that with a negative sign, okay? Because west is my negative direction. All right, now finally, we gotta figure out what question was the problem asking us. And it asks, what is Austin's displacement? Now we know displacement is represented by delta x, so we can put that there, and we are good to go. So I'm gonna cross off my categorize step. Now we are on the equate step. Now again, we don't really have an equation that we're using to solve this problem, but we do know that we're looking for delta x, and in order to find delta x, we need to combine, add up all of our individual displacements. So I'm gonna write this down, delta x equals, and we'll count that as our equate step. All right, now the final step of the ICE method is to evaluate. So I'm going to evaluate this equation, which is telling me that my displacement is equal to all of my smaller displacements added up. So let's go ahead and combine these. So again, remember, when I plug in my measurements, I'm going to always use parentheses so I don't get confused on what the negative sign belongs to, which measurement does my negative sign belong to, or confuse my numbers with each other. So we have -4 meters. Again, that just means it's 4 meters west. That's going to be combined with positive 22 meters. That is going to be combined with positive 17 meters. All right, that's going to be combined with a positive 6 meters. All right, running out of space here, and that is going to be combined with a -30 meters. Okay. So again, here we can see that our negatives, again, are just telling us that this displacement was heading west, which we deemed to be the negative direction. And the positives are just saying that that displacement is going east, which we've said is the positive direction. All right, so we're just gonna go ahead and combine these, all right? So let's see, -4 meters plus 22 meters. That's going to be a positive 18 meters, okay? Now let's go ahead and carry everything else down. Okay. Now, positive 18 meters plus 17, a positive 17 meters, all right? That's going to be a positive 35 meters. All right, so we just combine those. Again, we're gonna keep bringing everything else down. Okay. So let me also just show you all what I'm doing, what I'm combining. Okay, so I added those together to get 18. Then I added these together to get 35. All right. Now let's go ahead and combine positive 35 meters and positive 6 meters. All right, that's going to equal positive 41 meters. Okay. Carry down that -30 meters. All right, so let's go ahead and show that we combine the 35 and the 6. All right. And now I'm down to my final two displacements, which I have to combine. All right, and that is positive 41 meters plus a negative 30 meters, and that is going to equal a positive 11 meters, okay? So now I have two things that I can write as my final answer. So positive 11 meters is completely acceptable because I know from the conventions I set up that positive is the east direction. So I know that this is going 11 meters east. Or you could choose to explicitly state the direction. So I would say 11 meters east. All right. So this is how you can handle a problem where you're given multiple displacements.